Hello, welcome back to Beneficial Life Nodding. In this episode, I want to show you how I explore the idea of drawing spirograph using geometry nodes in Blender. Okay, so let's start from here. Okay, what is a spirograph or spirograph? Basically, this is a toy that I had when I was little, and I play around with it. It's basically giving you like a bunch of circle, like mechanical gear, where you can place your pen, and when you do that and then you start rotating the pen, you're starting to get this kind of like a flowery, like a flower or like a star kind of pattern, and you can use different pen color and you're gonna get all this like really nice circular pattern. You definitely have to play this if you haven't, but I think everyone kind of try this at some point. So this is the Wikipedia of the process. So in Blender I did made that, uh, and I have a few parameters to play with this idea. You might actually, if you study this, you might, okay, the result is like a flat curve, right? If you study this is kind of pattern that you might find in some architecture building, or like a maybe like a traditional plate or bowl. This one is flat, but I'll show you how you can make it more like 3D. Let me show you. Okay, let's see. Susan head. There's a dome on top of Susan head, but it could be like a bowl, or like a cover for your foods. But anyhow, I'll show you the process how I created this. The nodes seems complicated, but I will show you an easy way to transfer the formula. So, okay, spirograph, what is this exactly? It's actually, if you research a little bit further, like from Wikipedia, you will find out something called cycloid. Okay, so the pattern is like called cycloid, and there's also something called epicycloid and then hypocycloid. It's a lot of term, and there's definitely a formula, and this is rather simple. It's involving radius and angle, um, and we can get x and y coordinate based on that. But if I just ask AI, right, the AI could kind of help, but also at the same time, the AI, you can have Q&A, like chatting with AI, but sometimes you don't know where to go. So the graphing is actually important. Even though you are curious, I think it's still kind of nice to have a website that explain these things in one page, like article. So if you have a books and you work together with AI, I think it's much better. You can ask the AI while having a guidebook. So in this case, I stumbled into this website by googling, this one explain epicycloid and hypocycloid. I think it's one of them creates the star, the other one more like a flower. If you use the negative ratio, you get a flower or something like that, and the opposite is true. So yeah, this is the simple one. There's actually something that's a little bit more complicated. It's gonna give you something that looks like flower or like a cloud going in. Evolute, that's called it. They call it evolute, but you can have a read. Anyhow, we got a formula right here. Formula for the parametrics x and y to create the flower. All right, so where do we start? This formula, let's just grab this one, copy, and we're gonna translate it into the nodes, right? You can do it manually, but it's, you can see it's like a spider web. It's pretty crazy. So let's try it anyway from scratch. I will show you. There's actually an add-on. So this is Epi demo. First of all, install this add-on called Math Formula by author Wannes Malfait. So this is pretty, once you install this math formula, you can put math formula into geometry nodes quite easily. So you don't need to recreate the nodes manually. You can by using Shift A and then use math, and then deal with all this like sine, cosine. We only use those two, but typing it manually is like a bit crazy, right? So we need the add-on to translate our formula. This is the formula, and this is for the x, for example, and I will have to retype some of this. The bracket, just use the normal bracket, don't use the square bracket. So there's a variable like a and b. When we use cosine t b, this is the formula. Okay, it's not too hard, it's pretty basic. Copy this formula. This is for the x. Option x, oh actually option y, what is that? Okay, I forgot. Alt F. Okay, option F, type the formula. I can scroll to make it bigger, but anyhow we can copy paste the formula using Control V. So a, b, and then cosine, blah blah blah, a, b. This is the formula. You can memorize it, but I just copy paste it, and then Control Enter. Okay, doesn't like the cos. Okay, this one has to be lowercase. Copy again. Option F, Control V, Control Enter. Okay, magic. Suddenly we have the nodes being created. There's the parameter a, b, and the t. T, I think, is the angle. So we have this. Now I'll show you how I will recreate this from scratch. We need a points node with the number of the counts of the points. Compose. We can use the combine x, y, z. So this is going to be the x, right? It's going to plug into the position. Points goes out. So we have that sorted. The other formula the other formula is actually using just it's the same formula like above. The pattern is the same, just use the sign. So what I'll do, since we already have this, just duplicate it, and this is going to be using sine instead of cosine. Sine, cosine. Okay, and this one should plug into the second one because it's xyz to create the point value. And yeah, okay, and we already changed this to sine, and we have a few parameters. Now we have to deal with this. Okay, let's say we have this a and we have another a. We want to combine the two. Just hold shift and then right click drag. That's gonna create this branching. Okay, this is the a. You can see the point is reacting. So we have the b, and we all have the b. Don't worry about how complex the line is going to be. We just need to make sure we merge the line. We have the b. Okay, hopefully this works. So we have the t value, t and t. Shift right click, drag, combine the two. Now we can see there's like a spirograph kind of movement happening. And all we need to do is to use, maybe instead of t, use index value. Okay, now we have something. So we have index, which is, it's going to represent value from 0 until the last number of the index of the points. So we have this index value. Use an integer for the value. Plug is there, plug that into the points number. And then we need index. We can remap this value from 0 to the last value of points, and then this is the circular min and max. I think that's gonna be the angle, but anyhow, I think we get it. sort it out. We sort it out. There's a and b value, and also we can use points to curve. Okay, now we get something. I wonder why it's becoming ellipse. Maybe I did something. Maybe there's something in the formula that I did wrong. Anyhow, we have the flower, and we can start to play around with the parameter. There is this point that we can control, and there's also this minimum maximum. Okay, so I might have done something here that's a little bit wrong. Oh well, don't worry about that for now, but we get this anyway. We can control the integer value, and we have more or less like a spirograph. Now we just play around with this. I think the good thing about the AI, things like, yeah, you can ask what it is, and there's the Meta AI also give me the formula. You just need to use the multiplier and yeah, things like that. But this one, if we are curious with the ratio thing, the formula, okay, A is the radius of the fixed circle, B is the radius of the rolling circle. So the idea is to have, there's a big circles and there's smaller circles that's rolling around, and we are tracking the points on the circle that's smaller. If B is positive, this formula give epicycloid. If negative, is going to give you hypo. There's if for the B you can use ratio P and Q, and P and Q is like prime number. So if we make a division here, okay, use the math, divide. Okay, it's two value together that we can divide. 2 divided by 3, we get something. If this is minus 2 divided by 3, we get the opposite. There's this formula. So yeah, either it's negative or positive. It's going to give you like a flower. And the ratio will give you a design. I don't know why it's become ellipse like that. Let's just the one that's actually give us circle. This is the one I provided earlier, and I'm using the formula from Meta. So still cosine or sine, and you just need to fix the formula like that. This is the angle. Yeah, I think that's the formula. Okay, this is the correct one. So like I said, there's a bigger radius and there's a smaller radius, and we're gonna have like a flower. This is the integer. This is the I think that's the smaller radius. Let's play around with this. Use math, divide 2 divided by 3. So we have this kind of ratio that we can play around with. If this is negative, you're gonna get like a star kind of pattern, like the opposite, which is pretty neat. And you just play around with this angle. So that's how I create it. It's a yeah, there's, you can make this more complicated, but anyway, don't worry about it. That's gonna come eventually to you. You can play around with this. You can make this as complicated as you want, but start with this, understanding the simple idea first. Okay, combine x and y. We need the z as well. This is the output. Okay, the z probably can use the radius or the index. So if we use the index and then multiply this with a ping pong, for example, ping pong math formula, we can plug this in to the z, and we have that kind of wave. I kind of like this. It gives you beautiful pattern, and you can use this to create like a traditional wave. So the idea is, of course, there is a math formula behind it. This one is rather simple. Sometimes it takes just a bit of tinkering. We are modifying the formula or the parameter in some ways. The points turn it into curve type, set spline type to NURBS, so you get a smoother lines. So this is the ratio thing. I don't know why we have that thing coming out. Maybe we need to make it cyclic. But you should get the idea now how I set it up. So what I want to show you is definitely there's an add-on, this add-on math formula. If you open up the documentations, it should give you some ideas. Okay, this math formula actually turn your mathematic formula into nodes inside geometry nodes. It's super handy. I definitely have to give you the link. And then this is the original idea, the spirograph. Kind of understand how it works mechanically. You need to have the physical things to play around with it, and it's very, very fun to recreate it inside geometry nodes. You can ask the AI. The AI actually, you can have a chat, long chat, but also you need this kind of documentation, which is really handy. This is like all kind of curves that you can create using formula. So ideally, if you study with AI by yourself, the AI should be able to give you like blend files that recreate the thing, right? Not yet, but maybe one day it will just give you all these nodes. But when you know how to recreate it from scratch, that's another thing. It's just, it gives you better understanding. So but you need some kind of curiosity. It is complicated, but then to understand it, to understand the math, that's like something like an extra things that you probably can trigger more inspirations, maybe. But yeah, this is like beautiful. So the math formula will help you to draw the flower pattern. From the top view, you can see the pattern, and there's a parameter that you can play around with, and then you might find out, you might trigger an interesting result that you didn't think before. Who knows, you might create like a beautiful idea, like, you know, you can print this out. This is like a bracelet, right? Yeah, so that's pretty much what I want to talk about. I guess I could go like, maybe like, this is like a very simple video, right? Like trying to explain the things. Maybe what I'm missing is that how do I expand this? How do I expand this idea? what's the formula is useful for. See, it's gonna give you some more ideas. You can print it out, you can design architecture that's based on this, I guess. How do I make it a dome? How come my monkey head? Let's save this one. Let's open up. Yeah, how come this one shaped like that? Let's take a look. Geometry nodes. Select our cube. Oh. Okay, similar. But why is it shaped like a dome? That's my big question. I think that was like a mistake or something. Occasionally you get like some kind of equilibrium and you get that kind of thing. I don't know why. It's like magic. Okay, that's why is that value suddenly give me that kind of beautiful design. There you go. See, it's happening again. It's beautiful. But anyhow, that's pretty much the epicycloid and hypocycloid, or like cycloid formula that's I transfer into geometry nodes, and yeah, you can explore that further yourself. Okay, thanks again for tuning in, and I'll see you next time. Thank you. Bye.